Just,
What are you saying? You're saying something?
no, we can proceed.
Okay, let's go. So, question number 1A says, consider the quadratic equation of the form. You're able to see the question clearly, right?
Yes.
3x squared plus 2y squared minus 5z squared, plus 4xy minus 2xz plus 6yz. Express it in matrix. So first of all, we have a matrix A at the center, and we follow the squares. You remember first, right? So there is x. We get the coefficient. There's 3 here. What follows next is y, right? There will be 2 here and -5 here, right? And then from here, what follows after x? You remember those boring things I was teaching you. After x, what follows? In here, what do
Hello? Hello? Oh,
what should
sorry, I was distracted a bit. So we have x. We have x2. So meaning in this case, we'll have
what are you gonna have?
4xy.
Yeah, so it's xy.
4xy.
So it's
yeah. So
divide that by 2.
Sorry?
You have 2. You divide it by 2, right?
Oh, yeah.
Yeah, ayibala man. So this is what I said. Teacher said, x, xy, xz, yx, yy, and y what? Yz, zx, zy, and zz. Remember something like this that teacher talked about?
Yes.
So we are done with xx. We got what? To xy.
Xy.
After xy?
It's no, not x. Xy. Xy is 0. We don't have xy.
So after xy, what follows? That's the question. Here, what should be here? Xz. So what do we have? Xz is -2, right? So it will be -1, -1. See what I mean?
Xz.
There is x. There is xz here.
Yeah.
This one.
Okay.
Calm down. You will be fine. Okay? What follows next? Here. What should be here?
It's x in short, z. X to z, so meaning yz, which is 6.
Yz. No need of placing this. Huh?
6
This is a matrix. Is this hard? You've seen that these things are very easy. It's only that maybe you haven't gone through, yeah?
So meaning, where there are two letters, you have to divide by 2, right? Yeah. Okay.
These are quadratic forms. Very important. So you need the X matrix. And I said the X matrix is this one, which is XY, and Z, right? Vertical. So the transpose of that shall be X, Y, Z, right? And then you write the other side, the whole matrix, before it is converted. And before it is inverted, you have X, Y, Z, like this. So chubby. That's part one. You need to do this under, less than a minute. Get what I mean, eh? Any question? No questions, sir. Isn't it?
No questions, sir.
Find the determinant of a matrix A. So it's a 3 by 3 matrix. So you need to find the determinant of this. How do you go about finding the determinant of this? That's the question. How do you find the determinant?
You start the process that we are doing.
Yeah. You know how to find the determinant of a 3 by 3 matrix, correct? You still remember?
Yes.
Why I said you could pick maybe 3 here, then you delete the row, delete the column, those things. There'll be 2, 3, 3, -5. 2, this 2 will be -2. Delete the row, delete the column, you have what? 2, 3, -1, -5, plus -1. 2, 2, -1, and 3, like this. And then proceed. Right? So 3. 2 times -5, that's -10, right? -9, -19. Right. 2 times -5, -10. -3. So that would be 10, -10 plus 3, which would be -7, correct?
Yes.
-1, 6. 2 times 3 is 6, minus -2. That would be -8, yeah? +8. To be positive, isn't it? 2 times 3 is 6.
6, yes.
-3, -2. Remember this, yeah? Three times
2 times 3, that is 6. 1 times 2, which is -2. So this, which is +8. Yeah.
So 3 times 19?
57, -57.
Okay. Plus 14,
-8.
-57 plus 6, yeah? 14 minus 8 is 6, correct? And -51. Yeah. Happy?
Okay.
Like those recordings I've shared with you. When did I share them? Yesterday. You should not just fear them like maybe. Those are fully packed with a lot of information. Useful information. You've seen, huh? All these things are there. Seen that, right?
Yes.
Then there is that. What else we need now? You need Carey Hamilton. What? Do you need B or B is fine? That's a question. Never leave an enemy behind, eh? Ah, do you still remember how we find the Eigen values?
Yes. This one, no. This one, it's okay. I'm correct. I'm okay with this one.
You still remember how to use Carey-Hamilton theorem?
For normalizing eigenvectors.
This one, the Carey-Hamilton theory.
That one, I haven't gone through yet, but I think when I go through, I can.
Okay. That is interesting. Question 2. Error to my exams, tuliko is. Because if guys, I was to set for you an exam.
Yeah.
Okay.
Yeah.
Suppose there are 250 individuals participating in the Zambian labor market. So have you seen how important the things I taught you? These are stochastic matrices. They are all coming exact. Yeah? 250 individuals participating in the labor market. If an individual is employed in the current state, there is a probability of 0.8 that the person will remain employed in the next period, which means there is employed, yeah? Actually, we had something similar to this. What is just different are the numbers. See, moment. Yeah, so that's that. Just a minute. You are still there, yeah?
Yes.
Okay, just a second. Yeah, we are good. Right. Okay. Are we still connected?
Yes.
Okay. So let's go. So employed. Remember, period 1 is what? Employed. Period 2,
Yes.
unemployed. 1, employed. 1, 2, unemployed, then employed. 2, 1, employed, then unemployed. Unemployed, isn't it?
Mm-hmm.
You remember something like that?
Yes.
Very easy, isn't it? So
Mm-hmm.
let's go. What do we have? There is a probability of 0.8 of employed. Yeah?
Mm-hmm.
If the individual is unemployed in the current state, unemployed, there is 3% that they will find employment. Unemployed, then employed. Where do we put that?
Unemployed is the down below 0.8.
Unemployed in the current period, then employed later.
It's below 0.8. Since we are
There's something I've forgotten. I told you to read from where? From right to left, isn't it?
Unemployed, then employed. Yeah.
Do you remember?
Yes. So it's next to 0.8.
Very important. This will be 0.2. This will be 0.7. See what I mean? You're good? Are you fine?
Yes.
This is a column stochastic, isn't it? Remember last time when I told you you are reading this from right to the left, isn't it? That's what you saw in our example. Any question?
No question. That's all. This is it.
Yeah, that's why I'm saying the exams are too easy. We need to make them a bit harder. That's a stochastic matrix, isn't it?
Yeah.
Now, what is the equilibrium rate of employment in the market? Huh? How do you come up with the equilibrium rate of employment in the market? What did we say? You write this as 0.8, 0.3, 0.2, 0.7, then at XX. You remember now, right? Equal to 0. See my man?
Multiply, yes.
Actually, you can just say this is the X1 for what? For employment, right? X2 for unemployment. This will be 0.8 X1 plus 0.3 X2 equal to 0. See my man? Yeah. And then you have 0.2 X1 plus 0.7 what? X2 equals to what? To 0. Then you can use any of the two lines, right? by your choice. That's what it is. Right?
To find the value of either x1 or x2.
Mm-hmm. Very easy, yeah?
How am I doing?
You've seen that, but this is the same thing we did, isn't it? You remember something like this, right? Mm-hmm. It is something like this. But when we do the math, when you multiply by 10 throughout, this will be 2x1, right? Plus 7x2 equal to 0. You remember this?
Yes, I remember I will multiply by 10 of 2x1 plus 7x2.
So you have 2x1 is equal to negative 7x2. Yeah. What? You are following, eh?
Yes.
And these should always be treated in absolute what? Terms. Which means that they are supposed to be considered as positive what? Positive numbers. Right.
So if they are considered as positive numbers,
because it's a
have...
ratio. Ratios are always, just a minute. Hello. Sorry, I was interrupted. Some people called. Okay, so treated in absolute terms, you have a ratio 2 over what? For example, for this one, you have 2 over 9, right? 2 over 9 multiplied by 250,000 people. How much is this? What number is that?
55,000.
55,000 of the people are unemployed, right?
55,555.
5 Then 5, 5, 5, 5, 5, 5, like this. Okay. Recurring. There's no point.
Sorry?
There's no point anywhere.
All
right. Okay, so we can just put as 6. So it will be 55, 5, 5, 6. They are unemployed, isn't it? I told you to read from left to what? Like this small number is unemployed, which means the remainder, they are employed, right? Making sense? You can't have more than 200 people unemployed and just have a small fraction employed. Economy don't work like that. You get? You can't have unemployment more than 50%. Then in that leadership is not doing anything. Any question?
So
in short,
sorry, let me just get you back on the 2, where we are determining
the equilibrium rate of employment. It's the employment rate. It's equilibrium rate, not the number. So it's just that them 2/9 multiplied by 100. Because you're expressing it as a percent.
So the 2 is the x2, x1.
You got it, eh?
Yes. And the 9, sorry.
The sum. Chi is ratios. So you are adding. The total this side, there is 7, there is 9, the other side. Class last time, madam. Kajaka? Maningi. You'll be fine. I know if you can follow those, you have already passed. Any question?
No.
Atia?
No.
Okay. Yeah. Now, we go to B, right?
Yes.
Or there is a question.
No.
Suppose a firm in Zambia has a total cost by that amount. Find the second order derivative. You know what second order means?
Yes.
Second differential. Differentiate it, again differentiate. Mama, na? So it will be 2 Q.
This one I can do.
First derivative. Right? That's why they say, isn't it?
This one
second derivative, you can manage it, eh?
Yes.
You are a sharp girl. Something like this. 4 marks. Can you imagine you get 4 free marks by doing almost nothing?
Now you put first derivative. This is the what's this equation is 2q squared, meaning it's 6q. Here where you put 2.
Oh yeah. So the first one will be the first derivative will be 6, eh?
6 squared,
6,
yes.
6.
Plus
this will be 6. So this one will be 12.
Yeah.
Then 2 what?
Q. This is 12 Q plus 1.
So it will be 2 like this. Stay. Any questions? Derivatives.
Why are they this simple when we are sorting them together?
And when we are together, they are easy. When you remain alone, they change their mind. They become hard when you are alone.
I forgot to tell you, I forgot that I had research class this afternoon from...
You have a test?
No, research class from 16 to 18. So I've divided like, okay, if I can learn with you from 16 to 17, then I'll attend the last 1 hour.
Oh, yeah, man.
I forgot.
Don't worry. Let's do this one.
No, we can finish. I'll go at 16. I'll go at 17. Okay, it's from 16 to 18, so I can attend the last 1 hour.
Okay. Zcom. Sito period is I could convert each of the following quadratic expressions into metrics.
Can you go back to the other one?
No, this one, let's do it tomorrow because I need to introduce the Stochastic equations. Yeah.
Okay.
I need to introduce the Stochastic equations. Yeah, of course, it's basically on optimization as well. Just optimization. Okay. Just the optimizing, finding the profit, finding the output. But since there is a constraint, there is a what's this? Our constraint is like this. It's like this. Is not more than 100, which means that when you say Q1 plus Q2 should be less or equal to 100, which will make this, when you make this less or equal to, you can convert this to equal signs. Plus Q2 equal to 100. Then you can easily convert and set a Lagrange, isn't it? Do a Lagrange because this is constraint optimization. Anyways, because of the constraint you have been given, get what I mean? There are these limitations. So this is a constraint optimization. You introduce the Lagrange and then you'll be fine. So I'll comment on this a bit later. Probably by tomorrow, I should be able to say that. So that we are organized. Kylie, we don't want to mix up things. We want to talk about similar things so that it increases the ability to remember. See, my man? Happy? You will be happy one day. 9x squared. No, let's make a matrix. Can you make a matrix for this? Now I'm tired. Like you can just make them. Tell me what do we on the A one? How is the matrix?
This one is a 2 by 2 matrix. So for a 2 by 2 matrix, it's x, 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 y, y, x, x, y. So the first letter is 9. 9. So it's 9. The second one is the 6, and the opposite is 6. Then we have this is YY, which is 16. Yeah.
Yeah. It's too easy, yeah? Let's go to another one. Do the second one. Mm-hmm.
So the second one is also a 2 by 2 matrix. So the first one is 4, not 2, 4.
Why is it 4? Why 4?
Which one are we getting? Oh, the second one. Oh, okay, sorry. I was getting the discriminant. I was looking at the discriminant change and the second question. Okay, so it's 2, yes. So it's 2, then followed by, so this is 6v, which is 3, 3.
Okay.
And 1, negative 1. No, this is a 2. This is a 2 by 2, sir, not a 3. We only have 2 letters here.
Okay.
On B.
What letter?
Yes. We have U and V. Oh,
And W.
I can't see.
You can't see
sorry.
W.
I didn't see W.
U, V, W.
Okay, no, I've seen. Okay, so 2. Then 3, 3. We have put here. Then negative 1, negative 1.
No, we are listening.
Negative 1, negative 1, yes. Then here.
No. So the way how you approach this, first you put numbers in the major diagonal first. Put those that are in the major diagonal. So first diagonal is 2, right? What is the next entry?
The next thing.
The next entry. After U, then you go to B squared, right?
It's 6.
So follow first they put in the major diagonal. So U, V, then W, which is -1. Then that's when you start.
Wait. I think I didn't pick this point.
Start with the major diagonal.
Okay.
Then that's when you start now. The first 2 entries V squared. What follows after V? It's UV, right? Which is 6 divided by 2. It gives you 3, 3, right? After UV, what follows? UW, right?
UW.
That will give us -4, -4. Then after this, it's VW, right? -1, -1.
Let me just
Something
capture
like
this one.
We are good?
Just a minute.
Use the video. It's not in the luxury. It's in how much it means to you. But yeah. This is all he has.
Okay, done.
Okay, just a minute. It's not, yeah. Hello? Hello? Number. Okay. We are here.
One down. Then from there, go to X, Y.
We are here.
Yes, sir. I was just going through.
Oh, okay. I didn't get you. You were talking. Now, this one is more interesting. The second one, find the discriminant of the following quadratic equations. Find the discriminant. Yeah. I don't know whether there was a typo. I suspect, since this was a test, I suspect it should have read find the determinant of the quadratic equations, because you can manage to find the determinant of these, yeah? You know, because the discriminant, you know what a discriminant is? Discriminant means like positive, negative, b minus c. It's b squared minus 4ac divided by 2a. Now, what the discriminant means, the discriminant is this. You understand? So, yeah, this is it. It cannot fit into this conversation. It's different. Yeah. If they are asking for determinants, if they admit that that was a typo, it would have made sense, because you find you make a what? Matrices. You get. After making matrices from these, then find the determinants. Making sense. You get it, right? Yeah. Any questions?
No.
Find the eigenvalues and the eigenvectors. I think this conversation here, we have started it a long time.
Yes.
The issue of eigenvalues. That's where we started. Find the sign definiteness using the eigenvalues. You know how to find the eigenvalues to do sign definiteness, huh? Like when you, which means for this one, you have to form the what? The matrices. The matrices themselves. Then you find the eigenvalues for those matrices, right? And if all the eigenvalues are positive, then that is positive definite. It's just, yeah, the similar stuff, you know, because you know how eigenvalues sit. They sit like this. You know, they sit in the major diagonal. So if the second eigenvalues is positive, it means that this and that is positive. So that would be greater, positive definite, something like that. Nothing much hard. It's still the same conversation. In our next class, let me speak to optimization then. Just these two questions, so that you'll be able to relate properly. You know, that's that. Because it will be just two questions, then you'll be fine.